Okay, in this problem, I want to again use the method of instantaneous centers to figure out what this angular velocity of link BC is and the velocity of C is. So the first thing we want to do is we want to figure out what this velocity of B is, and if we look at link AB, its rotation about a fixed axis, we know how fast it's rotating. So if I draw this again, I have point B right here. It's moving on a circular path, and it's going to be moving in sort of this direction. So A is a fixed axis, so we know the velocity of B right here is going to be equal to the velocity of B is equal to this omega, the angular velocity of this bar AB, times the distance B is from the fixed axis. And we're given this, it's 0.25, so our velocity of B is going to be equal to 10 times 0.25, and this is going to be equal just to 2.5 meters per second. Now, I think I forgot to draw in the angles that everything is. So we're given that this angle right here is 13.6 degrees. This angle right here is 45 degrees. So we know that B is acting at 45 degrees from the horizontal and is 2.5 meters per second. Now we know what's happening with velocity of B. Let's look at this link BC to determine the velocity of C. So if we look at BC, let's draw this a little more upright so we don't get confused. We know that the velocity of C is just in the upward direction, so it's going just up. It's constrained to move just in this vertical axis. We know the velocity of B is over here somewhere at 2.5 meters per second. We don't know what the velocity of C is. So let's use the method of instantaneous centers to figure it out. We're going to extend a perpendicular line of the velocity through point C. So this is going to be the perpendicular line through point C, and we're going to extend a perpendicular line with the velocity through point B. So right here. And the point of intersection of these two lines again becomes our instantaneous center. And the two distances we are interested in determining is going to be this distance from the instantaneous center to C. So we are going to call that the distance C with respect to the instantaneous center, and this distance from the instantaneous center to B. And we are going to call this the distance of B with respect to the instantaneous center. Now we have a triangle. We have this triangle IC, B, and C. This is point C. And we know the length of this member BC. We know that it is 0.75 feet. And all we need to figure out now is the angles of this triangle. We need to figure out this angle, we need to figure out this angle, and we need to figure out this angle. Well, this angle is easy enough to figure out. It's this angle with the vertical we're given is 13.6 degrees. So if we subtract 90 from 13.6 degrees, we're going to get an angle of 76.4 degrees. So right here, it's 76.4. It's just this 90 degrees that is right here minus the 13.6 right here. Now, determining these two angles, it's a little trickier. It involves a little more geometry, but what we can do, if we look at what's going on in this member, right? So if we start to draw a ghost image of this member AB, we're given that this angle right here is 45 degrees. Now, we know this angle up here, this angle, let me get a good color that I haven't used. This angle right here is going to be 90 degrees. 45, 90, our last angle, or this angle right here is going to be 45 degrees. And this last angle we're looking for, if we add up both of these, subtract it from 180, we're going to get this last angle of 58.6 degrees. It's also possible to figure out what this angle is based on what we know that this is 180 degrees. This is right here is going to be 45 degrees, and it is possible to figure it out that way, but however you see this problem, no wrong way to find the angles unless you get a wrong number. So this is more problematic than the last video I made, because this is not a 90-degree angle, a 90-degree triangle. So we can't use SOHCAHTOA, unfortunately. But however, we can use the law of sines, and we have the sine of A, or I guess it's the sine of alpha over A is equal to B times the sine of beta, which is equal to C times the sine of, I guess, gamma. And what this is pretty much saying is that we can equate two of these sides, this side with its corresponding angle, and this side with its corresponding angle, put them together, and we can figure out whatever we're looking for. So we're going to want to use this 0.75. Its opposite angle is 45. So we have 0.75 over the sine of 45 is equal to, let's do the R of C first. So RC with respect to the instantaneous center over its corresponding angle is 58.6. So the sine of 58.6. And this is going, we can isolate this RC with respect to the instantaneous center, and this is going to equal the sine of 58.6 divided by the sine of 45 times 0.75, and this is going to be equal to 0.905 feet. We can similarly, look at this RB with respect to the instantaneous center. We can say that we want to use this again, so we can say that 0.75 over the sine of 45 is equal to RB with respect to the instantaneous center over the sine of 76.4. If we do the same procedure right here, we isolate this RB with respect to the instantaneous center, we get that RB with respect to the instantaneous center is equal to 1.031 feet. Okay, so the equation we have to use for instantaneous center, we have the velocity of c is equal to this omega bc times the r of c with respect to the instantaneous center, and we also have the velocity of b is equal to omega bc with times the distance of b to the instantaneous center. Well, we have this distance. We know what the velocity of b is. The velocity of b is 2.5. So we can say 2.5 is equal to this omega BC times 1.031 feet, and we get omega BC is equal to 2.425 radians per second. Now we can take what we just got for omega BC, plug it in right here. We have the velocity of c is equal to 2.425 radians per second times this distance right here, 0.905 feet, and we get that the velocity of c is equal to 2.2 feet per second. So our velocity of c is moving upwards. Our velocity, this angular velocity of BC, B is moving this way. So it's going to be moving this way.